So there's a question for Professor Verallen, which is what type of detector dosimeters will be recommended for in vivo dosimetry?
Okay, yeah, I showed them briefly. So some centers are using GAF-chromic film. The problem with GAF-chromic film is, of course, that you have to analyze them after the procedure, so it's too late to correct. It can only be used as a sort of a way of reporting the dose that was delivered, or verifying that the dose that you wanted to deliver was indeed delivered. But there is no way to correct afterwards or to make changes. And so for this reason, we are now experimenting with these scintillator detectors that look very promising. So at this moment, I think it's obvious my choice would be these scintillator detectors. But if you don't have access to them, I would suggest TLD or film to get started with, and then try to verify if you could use other detectors. That might be an option, but so to get started, film and TLD might be a good option.
There is a question. From what I understand, it's important to develop a team to do IoT. Who will be part of the team? Thanks.
And the question is to who? To everyone.
Is for everyone, and then there is another physics question. So it's about shielding. So if you are adding shielding to the OR, and those both questions are addressed to everybody, I think.
Okay, I can briefly answer already, and then maybe the others can jump in. I strongly believe in the multidisciplinary team. So if it would be my suggestion, I would say to involve everyone from the beginning, or at least every specialty that is needed in this team, to involve them from the beginning in the development of the entire IOeRT procedure. So this is the nurses, the surgeons, the radiation oncologists, and the physicists, so that they can work out the procedures as a team. And I think that's very important, so that they can work as a team and know each other's rules and roles, basically. Concerning shielding, yes, we are using shielding, and it's something that I didn't mention specifically, I think, but in my presentation, if you saw the OR, the walls are cardboard. So it's not even stone, it's a heat rock. And so we with the shielding segments that you saw on the slide, if you remember, it was very quick, but with these shielding segments and then the beam stopper behind the patient or below the patient, we have sufficient shielding to put this LIAC in a non-shielded OR.
What was the treatment planning system used for ultrasound guided treatment planning? And I can answer, or I can let Professor Verallen answer. It's a proprietary system designed by SAT, so it's all customized and has been developed in-house. So it's not a commercially available system. It's something coming from our firm. And there's another question, saying relating a question to Dr. Rubin, Dr. Intra. Since using electron IoT for breast will need the use of radioprotective disc, does this take a significant time to put in? Could you describe the surgical technique involved and how long it takes? Thank you.
The technique is very quick. Very quick, is very well described. I think we don't have time to describe every single step of the radiosurgical technique, but you can easily find it in PubMed. We published many years ago. In total, the radiosurgical technique takes maybe 10 to 20 minutes, but the important is it doesn't modify the normal criteria or the oncological surgeries. That's important, in my opinion. And after the normal period of training, you can realize all the procedure in maybe 20 minutes more. Isabel.
completely agree. We only use the disc when it's the full dose, and we don't use the disc if it's only for the boost. And it's easy. I mean, it's a disc that has 4 points, and you just stitch it into the pectoralis fascia. But I agree. I mean, as far as you get used, I mean, do 1 or 2. I mean, it's not, for a surgeon, it's not something that it will take time, and it's easy to do.
I would like to add a little bit to that. I'm not a surgeon, but I'm quite involved in the challenges of target volume definition. And if you apply oncoplastic surgery and you need to give a non-intraoperative partial breast irradiation, or later after whole breast irradiation a boost, can be very challenging to define the original tumor bed. So there is also a benefit of intraoperative radiation therapy if oncoplastic surgery is foreseen by delivering the dose before the tissue rearrangement. And this is not to be neglected, especially if we now have an increasing group of patients that can be treated with partial breast irradiation thanks to screening, thanks to improvement in other approaches. So it's an important issue.
For brain tumors, I treated in the past a few patients. They need to have the tumor in the hemispherium very superficial, because after resection, what is left is a cavity, and the cavity has to be filled by either by fluid or by wet gases or any system that will give like a false bolus into the electron interaction. One problem is that the craniotomy incision used to be relatively small, so to reach the area is quite difficult with large applicators. There was some good data in the early 80s coming from Japan, but this has been discontinued. And the use of other alternatives like kilovoltage and so, I see the difficulty of first dose distribution because of the steepness of the dose itself, then the duration of the applicator in place, which might fill the area with fluid and with other materials that can absorb that radiation. So in summary, with electrons is not being used lately and not being reported lately, probably because of the craniotomy size and the accessibility of the applicator to the tumor bed. And in terms of other systems, I have no experience at all.
I really thank you all. It's been great listening to you. We exceeded a little bit the time, so thank you for your extra time granted and for your wonderful availability. We are always available for questions, so just drop us an email. And I wish you a fantastic weekend. Started in Asia before and about to start in Europe. If nobody has any further question, I will say bye-bye to everybody.
Thank you.
Thank you, everyone.
Thank you so much, and use the mask. Bye-bye.
Thank you.
Thank you so much. Bye to everybody.
Bye.